In this video, we're going to start Chapter 4 and just talk about some definitions. Most of these are pretty simple, and I'll go through pretty quickly. First of all, a critical point. A critical point is anywhere where the derivative equals 0 or does not exist. So a spot where there in the original function would be a horizontal tangent because the derivative is 0. We've talked about that before. If the derivative is 0, there's a horizontal tangent. Or the derivative doesn't exist, meaning the original function wasn't differentiable. So again, a critical point where the derivative is 0 or does not exist. Something is said to be an absolute maximum. I'm sorry that when I change to italics, it gets a little messed up there when I record. If something is said to be an absolute maximum, that means that that spot, f of c, is greater than or equal to every other spot in the function. And I hope that makes sense. If you have an absolute maximum, like this value would be right here, that means that it's greater than or equal to every other spot on the function. There's nothing as high as it. Now, it says equal to, so of course that means that there can be more than one as long as they are the same point, right? There can be more than one. Something like sine would have an infinite number of absolute maximums. They just are always one. An absolute minimum is a spot where every other spot on the function is greater than or equal to it. So again, it's the lowest spot on the function. Absolute maximum, highest. Absolute minimum, lowest. But you can have more than one as long as they're the same. The extreme value theorem says that a function is going to have a maximum and a minimum as long as it is defined at its endpoints. Okay, and of course I drew up this picture specifically so you can see the absolute minimum is the left endpoint, the absolute maximum is the right endpoint. But if I were to make these endpoints be undefined, okay, so if I were to, instead of having them be a closed circle, if I were to have them be an open circle, then, something like this, then it wouldn't have an absolute maximum. Okay, and if I did this, open circle here, it wouldn't have an absolute minimum. The extreme value theorem says as long as it's defined at its endpoints, it will definitely have a maximum and a minimum. Now I just want to draw a couple quick sketches. Okay? First, I want to draw a parabola. And I'm going to do this. Okay, so it's not defined at its endpoints. And I do this because I want you to see that this thing still has an absolute maximum. It just doesn't have a minimum because the endpoints are not defined. But just because the endpoints aren't defined doesn't mean it won't have a maximum or a minimum. If I had something like this, okay, let's say it wasn't defined here, went up, came back down, came back up, and it wasn't defined at its endpoints, it still has a maximum and a minimum. The extreme value theorem just says defining the endpoints ensures that it will. But it might have a maximum or a minimum if it didn't have defined endpoints. The best example, I think, is a line. Okay, if I have a line like that, and it's not defined at its endpoints, it's not going to have a maximum or a minimum. Okay, if it's just a line segment like that. But again, not being defined at the endpoints doesn't mean it definitely won't have a max or min. It just means, the extreme value theorem just means, if it's defined, it definitely will. A local maximum is the point that's the largest of the points around it. Okay, so if I point out a local maximum right here, there's another local maximum right here, local minimums, of course, here and here. And the local extreme value theorem says if a function has a local max or a min, so here, 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 or here, and the derivative exists, meaning it's differentiable, then the derivative is 0. Okay, and again, that comes back to horizontal tangents. If I draw a tangent line at a max or min, as long as the function's differentiable, the derivative will be 0. Okay? So local maximums in plain language are just the highest point. Local minimums are the lowest point. And the local extreme value theorem says if there's a local max or a min at a point and the function's differentiable, the derivative is equal to 0. So you look here, there's a maximum right there and the derivative is 0. There's a local minimum here, but because there's a corner or a cusp right there, the derivative is undefined. So it just means as long as the derivative exists at a max or min, it'll be 0. Another example of this would be something like this. It definitely has a maximum, but but the derivative at the maximum doesn't exist, so it can't be 0. One other quick example I'm just going to draw here that gets at the heart of the definition of local max or min. Say it's something like that. And the question was, is this spot right here the local maximum? A lot of people would say no, it's not differentiable there. You're right, the derivative doesn't exist. But the definition of a local maximum simply says, is it the highest point in its space? Yes, that is the highest point in the space. So that is a maximum. So let's kind of close this all up. If something is differentiable, then a local minimum or maximum occurs when the derivative is 0. Okay? As long as it's differentiable. An absolute maximum or minimum occurs, well, you look at this graph, and again, I drew this specifically. The local, or the absolute maximum, is actually also a local maximum, where the derivative is 0. So it could be possible that we're looking for the same exact spot to get an absolute. And remember, local just means of the stuff around it, it's the biggest. Absolute means it really is in the whole graph the biggest. Well, I drew this, as I said, specifically so you'd see that the end point is the minimum. Well, that's not a local. I mean, you could say, well, it's the lowest of the stuff around it. And sometimes people will classify the end points as local minimums. But for sure, for an absolute, we have to check it. So it could also, for an absolute, occur at an endpoint. So let's use these ideas and find the maximum and minimum values of the function on the interval from -2 to 1. Now you see this little man here I have that's running for office. That's because what we're about to do to find the maximum and minimum values is what is called the candidate test. Okay? Now the candidate test says we should identify all the possible places a max or min could be and then try them all out. Okay? It's actually a pretty easy test. Now the first thing, thinking back to the last slide, a max or min could occur when the derivative is 0. So let's find the derivative. Okay, it's going to be 12x squared minus 20x. Let me do a little factoring. Okay, I could take a 4x out of each term and I'd be left with 3x minus 5. So I'm going to take my derivative and set this equal to 0. So using what we know about functions where there's 0 and factoring, of course one of the answers is 0 because 4 multiplied by 0 is 0. And the other is what would make 3x minus 5 equal to 0. So if you've kind of forgotten how to do that, let me just kind of put this over here. 3x minus 5 equals 0. Add 5 to both sides. Divide by 3. Okay, so 5/3 is the other spot. Now, one of these, I have two, these are called critical points. I have 2 critical points, but really I only care about x equals 0 because I told you that I'm only looking for the maximum and minimum values between -2 and 1. 5/3 is bigger than 1. So, absolute maxes and mins occur when the derivative is 0 or at an endpoint. So candidate test says, okay, let's plug in the critical point that we found. Let's plug in the endpoints that we have to the original function and see which one's the biggest and which one's the smallest. Well, if I plug in 0, I get 0. If I plug in -2, I get negative 72. You can check that. If I plug in 1, I get negative 6. So, if I'm looking for the biggest one, the biggest value here is 0. This is the maximum value right here. If I'm looking for the smallest value, that's negative 72. So that's the minimum. Now, I did graph this. I wanted you to be able to see what that looked like. So let me grab the graph. And what you can see here in this graph is that negative 2 is absolute in this interval from negative 2 to 1. That is the absolute minimum. It comes up at 0. We hit a maximum, and then we come back down. And negative 6 to us right now is nothing. But the absolute minimum occurs at negative 2, negative 72, and the maximum is at 0, 0.